What is time and how do we measure it? Time is something that cannot be measured without a physical or spatial change. Like the sun. When the sun moves, we measure time. Day, night, evening, morning. Or a pendulum. Or the rotation of minute hand, hour hand, and the second hand on the clock. Or the vibration of a crystal. This is how we measure time, through physical changes. But if every single thing in this universe becomes motionless, changeless, down to the atom, then how will time be measured? Will time become frozen? But it is really the physical things that are frozen. How is time frozen? If time is frozen because physical things are frozen, then time is not flowing. Time is dependent on some physical things, on physical motion, on physical change. So let's imagine, what if there exists a multiverse, an omniverse, a god? What if all of them are frozen? What happens then? Does time still flow? Like every single thing that ever existed, that ever exists, that is has is not moving. It is stationary with respect to each and everything. Now is time frozen? How will time be measured now? Like it cannot be measured. So if our thoughts are frozen, if we ourselves are frozen, then time is also frozen, right? So time is something that is not of another dimension. It is physical. It depends upon physical. Rather, it is a vague concept that we humans have created. So let us consider another thought experiment. Let's say we are floating in a lonely corner of the universe where there is nothing but we and a sphere. Now let's say that the sphere becomes big very fast, and after reaching a specific size it starts becoming very slow, very small, very slowly. So basically I'm talking about rate here. It is becoming large at a very fast rate, and it is becoming slow at a very slow rate, small at a very slow rate, sorry. Now we perceive it as being fast or being slow. But what is fast? Fast is just a big change over some time, and slow is just a small change over the same amount of time. That means we are measuring time. So even when we are alone, we can measure time. Well, uh, because we perceive time that way. So there is a difference between perceiving and measuring time. So we measure time through external objects, and we perceive time through biological clock that is inbuilt within us. So let's take another thought experiment. Like, why do we feel that a snail is moving very slowly? Uh, because like when the snail moves from point A to point B, we can think of 100 different things within that much amount of time. So we think like, yeah, I thought so much, like my heart beat like 24 million times within that time period, and I got bored looking at the snail. That is why I am perceiving it as it is slow. But whereas if it was a snake, how would I react then? Like it came to from point A to point B, uh, when I couldn't even react. I wasn't even able to react. Like I had half a thought, like that this is a snake, be scared. I had just this much thought, and the snake came from point A to point B. Whereas the snail took a lot of a lot of thoughts for me to occur. So maybe we perceive time on the basis of our heartbeat, on the basis of our respiration, how we respire, how we breathe, because that is also like a pendulum, I can say, right? So inhale, exhale at a specific rate, and the peak at which we can think, maybe because of that we cannot think faster than a specific rate. We can think only like some thoughts per some time. So time is external object, so time measured by external. So basically what it concludes is that time does not actually exist. I mean, maybe it exists, but there is no way for us to measure it without the change in physical or spatial dimensions. So even if time does keep constantly flowing, we cannot measure it, and it is of no use to think of it as always flowing or as constantly flowing. Even when we are talking about physics, when we are talking about a distance time graph, a velocity time graph, a something time graph, then what is the time that we are taking in it? Yeah, it is just a motion of something. We are comparing a motion of pendulum to the distance traveled by this object. Distance time graph. Distance traveled by this object compared to the motion of this pendulum. So we can even interchange that. We can take the motion of that object as to be constant and the motion of this pendulum to be the one that is variable. So for example, let's say if an object is accelerating at a specific rate, what does that mean? That means that in one complete round of a pendulum, it has moved, let's say, a specific distance. Now in another round of a pendulum, it has moved more or less, not the same, alright, distance. This means that the object is accelerating. But we can also assume that the motion of the object from point A to point B to be the basis of our calculation of time. So the object moves from point A to point B, it is constant, it is the time. Now the motion of pendulum becomes accelerated. Like the pendulum is not moving at a constant rate. Right, so this is what we mean by taking a distance time graph. We are assuming something has to be time. We are assuming the vibration of a crystal to be a time. So, yesterday this thought occurred to me when I was learning about differential equations, and I looked at slope and time graph of something, and I thought that what if I replace this with that. So basically how we perceive time through a biological clock, and then we compare this biological clock to an external clock that we have made. This is how we perceive time. So like let's take the example of the snake. Let's say the snake is coming towards me. Now I want to pull my leg away from the snake. My leg is over there. I thought that I will pull my leg. Now I started pulling my leg. Within this much amount of time, that snake has reached me. Right? So this is why the snake is fast. Whereas if there was a snail instead of a snake, which moves really slow, then I would do a Bharatnatyam and still the snake won't reach me. So that is why the snake is slow. We are comparing it with our motion now, and on that basis we are calling it slow. So time is relative. Time is not absolute. Time is relative. We are measuring time with respect to our biological processes, with respect to that motion of that particular clock or the motion of this particular object. If it is moving and we assume its motion from point A to point B, a specific distance, to be constant, then even if that object was accelerating in reality, we cannot tell that it is accelerating in reality. It is a false statement to say that it was accelerating in reality. That is not a true statement. Maybe the pendulum was accelerating. Nobody can tell that. Only our thoughts, maybe our thoughts were accelerating. We can assume that too. So that is what is meant by time. We perceive time through our biological clocks, and whatever we see fit through our biological clocks, we assume that as linear, as constant, as the unit of time. like the motion of pendulum, we see it as constant because it aligns with our thinking process, our thinking speed, and our biological clock. So we are assuming our biological clock to be the one that is absolute. But even our biological clock has many flaws. And so we assume the motion of something else, like a pendulum, to be the one that is absolute. But we still cannot say that that one is the absolute one. Because I can say that the motion of a so called accelerating object is constant, and you will not be able to prove me wrong. So that was my point. Now let's take another example of a bike. Let's say a bike, its sound is reaching to my ears and I'm processing it. Let's say by the time I process, the bike has gone. Right? By the time I process, the bike has gone. Alright? So I'll think that, oh, the bike was very fast. Whereas if my thinking speed somehow magically increased by a lot, so if my speed increased by a lot, then I would realize that the bike is there within a millisecond or even in less time. So now I have realized that the bike is there. Now I'll get other thoughts and other thoughts. So I'll be bored that what that bike is has been there for a long time, because I've got many thoughts within the passing of that bike. So I'll think that the bike is slow. Even if the bike was moving at the same speed as it was earlier, but since my processing speed has increased, my brain's processing speed has increased, I will realize that the bike is slow. This is how we perceive time.